Hello everyone. In this video we are going to discuss about 80386 microprocessor. So this video contains introduction to 80386 microprocessor and their features, architectures and application. So firstly introduction. So commonly there are two versions of 80386 are available. First one 80386DX and 80386SX. 80386SX was developed after the DX for application that didn't require the full 32-bit bus version. It is found in many pieces that same basic motherboard design is used as the 80286. Most application less than the 16 MB of memory. So the SX is popular and less costly version of the 80386 microprocessor. 4 level of protection, uses 3-stage pipelines, supports multitasking with protection, on-chip cache memory for TLB, pipelined instruction execution, memory management unit, high-speed numeric support via 80287 and 80387 coprocessor. It can operate in real, protected and virtual mode. Architecture of 80386. The internal architecture of 80386 is divided into three sections. First one, central processing unit. Secondly, memory management unit. Thirdly, bus interface unit. So this is the architecture of 80386. So generally, central processing unit consists of execution unit and instruction unit. Similarly, memory management unit consists of segment unit and paging unit. Lastly, bus interface unit. Execution unit has 8 general purpose and 8 special purpose registers, which are either used for handling data or calculating offset addresses. The instruction unit consists of a prefetch and decode unit. The instruction prefetch unit is used to fetch instruction in advance to implement pipelining. While the execution unit is executing the current instruction, the prefetch unit fetches the next 16B of the program and stores it into the prefetch queue. The prefetch queue requests the bus unit to fetch for instructions, and if at same time the EU also requests, then priority is given to EU. While the EU is busy, the instruction decode unit decodes the opcode bytes received from the 16-byte instruction code queue and arranges them in a 3-instruction decoder instruction queue. After decoding, pass it to the control section for deriving the necessary control signals. The 64-bit barrel shifter increases the speed of all shift and rotate operation. The multiply divide logic implements the bit shift rotate algorithm to complete the operations in minimum time. Even 32-bit multiplication can be executed within 1 microsecond by the multiply divide odds logic. Execution of any program needs arithmetic and logic operation, and this is performed by a 32-bit ALU. Operands for ALU can be taken from register file, which contains all general purpose register. Additionally, it has a 32-bit flag register. These flags give status of the current result. A protection test unit gives protection to the program or instruction based on their privilege. There are 4 privilege levels. Usually, kernel of the OS code has highest privilege or protection, followed by OS services, second and third level, and the lowest for applications. For example, like for critical OS code and data can be protected by keeping them in one more privileged segment than those that contains application code. This prevents application code from accessing the OS code and data. It is usually used to detect problems and bugs. Let's not go into detail. The memory management unit consists of a segmentation unit and a paging unit. It is used to determine the physical address and the logical virtual address. 80386 microprocessor implements 64 TB of virtual memory using segmentation and paging. Hence, the memory unit is subdivided into segmentation unit and paging unit. Segmentation unit allows the use of 2 address components, segments and offsets for relocability and sharing of code and data. Segment unit allows segment of size 4 GB at max. Paging unit works under the control of the segment unit. Example, each segment is further divided into pages. The virtual memory is also organized in terms of segments and pages by the memory management unit. The segmentation unit provides a 4-level protection mechanism for protecting and isolating the system code and data from those of the application program. Segmentation is compulsory while paging is optional. The paging unit organizes the physical memory in terms of pages of 4 KB size each. The segmentation unit converts the 48-bit logical address, actually 46B 2B for protection, into 32-bit physical address, while the paging unit converts the 32-bit linear address into 32-bit physical address. If paging is not used, the linear address itself is a physical address. The control under attribute PLA checks the privileges at the page level. Each of the pages maintains the paging information of the task. The limit and attribute PLA checks segments limits and attributes at segment level to avoid invalid access to code and data in the memory segments. The bus control unit has the prioritizer to resolve the priority of the various bus requests. This controls the access of the bus. The address driver drives the bus enable and the address signal A0 to A31. The pipeline and dynamic bus sizing unit handle the related control signals. The data buffers interface the internal data bus with the system bus. Applications of 80386 microprocessor. The 80386 microprocessor is currently in use on several spaceflight projects. Some mobile phones also used the 80386 processor, such as BlackBerry 950 and Nokia 9000 communicator. The 80386 is currently used in Hubble Space Telescope and Solar Anomalous Magnetospheric Particle Explorer. Features of 80386 microprocessor. Manufactured using Intel's complementary high-performance metal oxide semiconductor 3 process, 8 general purpose register of 32-bit, 32-bit address and data bus, supports 8-bit, 16-bit, 32-bit data, prefetch queue and 16B, very large address space. Example, VM of 64 TB and